All right. We certainly can. Like other previous. How previous do you want?
This one.
You taking pictures?
Thank you.
Do you know they're?
Yes, I know. I mean, I like to keep it in here.
I see people do that, and they're like, "How do you keep track of all those pictures?"
I'm not taking a picture ever.
Right.
I'm just taking.
Right. The ones that you think are good. All right. So now to understand these a little better, let's look at how to take exist. And this is just quick and dirty exist. We'll do some fancier negations. We're going to do negations. All right. So what does this say? It says there exists a girl that loves. All right. So we want to take the negation of that. Right. There doesn't exist a girl that loves. All right. What we're going to want to do is we're going to change this into a different sentence. We want to bring the negation in. Yeah.
For the last slide.
Yeah.
So essentially what you were trying to just focus on is like the order of like precedent almost.
Quantifiers.
Yeah, quantifiers to make sure that, especially if you want it to be one kind of, especially when it comes to
Yeah.
like, there exists.
Yeah.
It's imperative that it comes first.
Yeah. You got it. The order. That's what I'm going to keep doing, and we're going to keep doing examples in which I'm going to give you a sentence with the quantifiers in this direction, and then I'm going to swap the order, and we're going to see it means something different. All right. And why do I do that? Was because I made these slides when I was really fixated on this example we just did, and that students didn't know how to swap them. All right. All right. So now let's say it's not true that there exists a girl in this room that loves. Right? What are we going to say instead of that? This would be the same statement. How do you know that there doesn't exist one? What? Yes, all girls don't love, right? All girls don't love, right? You probably even did this in 1019, right? There's not a girl for which this is true, right? Then for all girls, it's not true, right? Here we go. We bring the negation in, and it turns the exist into a for all, right? Everybody get that in their soul? I mean, you can memorize it, but you should also know, right? If it's not the case that there exists somebody, then for all, it's not the case, right? Right? And remember De Morgan's law. This is just, right? Remember that the exist is a big or, and this is a big and. And when you bring the negation in, it switches the and to an or, right? See the same? Except in this, what's the difference? Here, it's an or over two things. Here, it's an or over an infinite number of things, right? So what about it's not true that every boy, because there exists a boy for which it's not true, right? Right? If I want to say for every boy something is true and you want to prove it's false, you just have to do proof by counterexample, right? You can do one example of a boy that's not loving, and then that proves that they're all not loving, right? All right, so now let's bring it in, right? There exists the boy. It's not true that there exists a girl, right? So it's not true that there exists a girl. Then for all girls, it's not true, right? Everybody see that? We brought the negation in and we switched the and and the or. All right, it's not true for all boys, and hence there's a boy in which it's not true. Right? Everybody see that? Everybody do this? You guys have done this in 1019? Right? All right. All right, here, that's in formal logic, the Forall is always over all objects in your universe, right? But in informal logic, we do this all the time, right? So we're going to talk about it, right? So here I'm saying there exists a dog that loves, right? And I was kind of cheating up here where I was assuming that G's were girls and B's were boys, right? And you can imagine in informal things starting off with saying B's donate a girl and a boy and G's, and then you don't have to write it down every time, right? But here, what is this saying? If you remember 1019, dogs is a set, right? You have this symbol here. It means objects is in the set, right? So these dogs are in this set. And this says there exists a Y that happens to be a dog. And what's true about that dog? He loves, right? Everybody good? All right. So we bring in the negation. And what is it saying? It's saying it's not true that there exists one. All these dogs, they're just not loving, right? You should meet my nephew's dog down at home. He growls at me all the time, right? We live together and I feed him. Dude, don't growl at me, right? Now, what about cats? Do we know anything about cats? We're not talking about cats, right? All right, so what does this say? We don't negate the set thing, right? For every dog, the dog doesn't love, right? You see, we're talking about dogs. So we stay in the dog domain, right? Everybody good with that? All right, you say you're good with it, but you often get it wrong. All right, so here's another statement. Here I have a value X, and here's my X, and I'm claiming that there exists a Y less than or equal to X, right here, Y is less than or equal to X that loves, right? Everybody see what we're saying? Here we have some X, we're saying everybody less than X loves. All right, now we want to negate this. Right? Oh, I thought I would cheat with you. I should always cheat with you, right? What people do wrong is they see that less than or equal to, and they turn it to a greater than, right? They negate it, and you don't want to negate it. Why? Because just as we were talking about dogs, we're talking about values that are less than X. Right? You hear what I'm saying? So we're talking about the set of dogs. There doesn't exist a dog, then for all dogs it's not true. Right? There doesn't exist a Y that's less than X, then for all X less than X, it's not true. Everybody see that? I think I should change this slide too to tempt you to be wrong first. Right? You hear what I'm saying? All right. All right, now I've been kind of implying, yeah.
So it's not necessarily the premise that you apply the negation to, but like the whole thing. Because like technically, wouldn't it be like right if you like flip the thing to say like
Yeah, so let's write what it said. It's not true that there exists an X less or equal to Y where right? So what are people often doing? They say for all X greater than Y loves y is not true, right? Everybody can see they're tempted to do that, right? They're tempted to bring in the exact x, the negation, and right, we negated this, right? So why don't we negate this? Right? And the reason is the same as here. Here we have our number, we have our number line in x. And these guys over here are dogs, and these guys over here are cats. Right? And this statement here is talking about the dogs. Right? There doesn't exist the dog with a certain property. Right? So this one here is talking about cats. Right? Do we know anything about cats? Nothing. We know nothing about cats. Right? What do we know? We know that for all dogs, they're not loving. Right? Does that make sense? Okay, two things have changed. Do you ever, yeah?
So suppose if you like negate this the second statement where there will there be switch back to the one in the basket on top?
So if we negate this, this one's talking about cats. So we negate it to, what's the first thing? For all goes to exist. There exists an x. Which x's that we're talking about? We're talking about cats. And we bring the negation in. So negation is no negation. Right? Now, if we negate, does that make sense? No.
So you're just saying that for all x they're for all x, in sense that y.
For all x that are bigger than y, they love. Right? So here's x, right? And we don't know anything about x itself, but everybody over here are lovers. Right? Excellent, right? Versus if you take the negation of this, you get back to this. Everybody bigger than y, they don't love. Oh no, oh here, no, I read this wrong. Sorry. This says there exists one, right? So we don't know that these all we're just saying is there's at least one over here who loves. Right? So it says there exists somebody bigger than x. Oh, I switched. Did I switch them? Oh, all of this is switched from the slides. Sorry. Everybody good? That's why you never, I used to argue for years, I argued, are Blackboard presentations or PowerPoint presentations better? Right? And then I realized that was the wrong argument. What's absolutely true is my PowerPoint slides are better than my Blackboard presentation. Because I get everything muddled. Right? I got a smile out of that one. All right? All right, are people sort of following this? All right. So now we're going to bring in these games. And I guess I always intrinsically knew these games. This is one of the things that's bad about old people, right? You say, well, when did you know about For All Exist? Always. I knew it when I was in kindergarten, right? And is that true? Probably not. When is the first time I saw this game? Well, there was this postdoc when I was a master's student at Toronto, is when they were talking about this game. All right, so I don't assume everybody knows it, yeah.
And so, I must have a statement again. So suppose if you negate it, you get that, but then doesn't the sign have to be flipped? You know,
This sign,
Isn't it, doesn't that sign need to be flipped to, more than for if it's negation?
yeah, that's why we're doing this example, because everybody wants to flip it. And when we go from there exists the dog to the negation, are you gonna suddenly go to cats? No, you're not, right? You're not gonna split from dogs to cats. So why do you want to flip from x's that are less than y to x's that are bigger than y? Right? Are these here are the cats, and over here are the dogs, right? And are we talking about cats, or are we talking about dogs? We're talking about dogs. So don't just start telling me things about cats. Right, does that make sense? Yeah,
So it's less about being logically like cohesive, but more about like the focus of what you're actually trying to do with the proposition. Because like you could technically like write out a way to make it logically cohesive to flip it, but it doesn't really make any sense because the focus of what we're focusing on is the premise of dogs as opposed to cats, because we don't know that much about cat first.
all right, so, if you were to read, George's book, you would never see this, right? It's just not allowed. And then you might ask George, why is it not allowed? And he would probably say, Gödel didn't do it, and we do everything the way the forefathers do it, right? And then, so they don't teach it. And then students come across it in the real world, because people do it in the real world, absolutely they do it. They talk about for all politicians, there exists a voter, right? They're doing it all the time, right? And then students get it wrong, right? So what I'm saying is people in the world do this, and you should do it right. Right? If you were to ask Gödel how to flip this, he would know how to flip it. Right? But why did he put it in his logic? Because they're trying to make their logic as small, fewest definitions as possible. Right?
So it's about the cohesiveness. I was like, well, what are we talking about?
Yeah. And I'm trying to make it as inclusive of what you will see in the world as possible. Right? And no mathematician would want you to go from this to this. Right? And if you were to ask them why, they would probably say, here we're talking about x's that are less than y. Where are you talking about x's that are bigger than y? Right?
Get confused now.
Yeah. Right. Right. So in fact, what I'm trying to do here is point out things that people do wrong. Right? And making sure we get them right at the beginning. It's like when you're learning to play the piano, and you say this and you do it some weird, awkward way. Your teacher is going to say, no, from the beginning you got to do it the right way. And they say, oh, I don't mind doing it. No, because when you get good, you want to do it the right way, and you might as well learn to do it the right way at the beginning. Right? Everybody good with this slide? And we'll cycle through these things again. All right. So in 1019, they taught you logic in a very short length of time. You had to prove things in a very short length of time. And since I do it for a whole term here and the students don't really get it, there's no way you're going to get it in 1019, right? But still, you might think about how would you, you look at the statement, and first you want to know, is it true or not? Now, is it true depends on your definition of for greater than, for example, right? If I define greater than to mean something weird and I define X and Y to be bananas, then who knows whether it's true, right? But, you know, you see this with a greater than, you can assume it's either the integers or the reals, right? And I would tell you, over the integers, over the reals, is this true? What does over mean is I tell you what the universe is, right? So, for every X, there exists a Y that's bigger, right? In fact, I think we played this game already, right? Let's play the game. We'll go come up with a number, and the one with the bigger number wins. You go first. What? You lose, right? He can go a billion, right? Then I go a billion, I forget how many billions in one, right? I'm gonna win. Why? Because for every number he says, there's a number that I can say that's bigger, right? Everybody see that? And you'll see how it's also a function, right? I have in my brain a function. My function is add 1 to it, right? So anything he's going to say, I'm going to say plus 1. That's a function from his X to my Y, right? Yeah.
So if you were to say like infinity, like would you?
That's not an integer then.
Yeah, so it's more of a concept.
No. It's more about what is our universe, right? And in fact, we're gonna do exactly your example sometime, right? And is this always true? Well, suppose we're over our universe is the integers plus infinity, right? Now is this true? No, because a counterexample is nothing bigger than infinity, right? So the statement's not true if you include the infinity. It is true if you don't include infinity, right? And so what's true about, and it's same with induction. You know, we're going to get into induction, right? If one's true, then two's true, three's true, right? Then induction says they're all true. Well, is it true for infinity? I don't know. I'm over the integers, there is no infinity.
Yeah.
Right? Everybody good with that? In fact, this is kind of what does this say? To me, what this says is that there's no infinity. Right? Because whatever integer you give me, I can give you a bigger integer. I.e., there's no infinity. There's no biggest integer. Right?
Yeah, because as long as it's
right?
you just add 1.
Yeah. All right. So now how do we play the game? Right? The statement about integers. Something's true for all integers. What's true about that integer is that there exists somebody who's bigger. Right? Right? Now, which X are we talking about? Right? Well, we're talking about all of them. But I don't know how to, but over here, we're only talking about one X. Here we're talking about all X. So which X? Right? Well, who comes up with it, right? You come up with some X, I come up with a bigger one, right? 0, I come up with 1, right? We can talk about this. Integers go on forever, but they never stop at infinity, right? Right? So I have a hot tub and I've had a party every week for the last 25 years. And people come out and say, is there room? And what everybody says in unison is that there's always room. All right? Our record is 15, right? So this says no matter how many people you have in the hot tub, right? You can always put another one. And the joke is that means you can put an infinite number of people in this hot tub, right? All right. All right, here's the game, right? Everybody remember this game? Trillion, bigger, right? It's a big number, we can go bigger, right? So Right? I'm just saying it's an important game because we use it all the time. All right, so if you were to take 2001 from me, I would really in fact, anything, you take anything, computer science from me, I'm going to separate out what happens during compile time versus what happens during runtime, right? You're writing a program and you try to compile it, it has compile time errors, right? Then you compile it and you run it and you have a runtime error, right? What's the difference? The compile time errors happen without knowing what the input is, right? A runtime error depends on the input, right? What doesn't depend on the input? How big the code is, how many variables you have, right? Right? So you have during compile time, you have to choose the size of your Java program, right? And then somebody else chooses the size of your input. And how big are they going to make the input? Probably bigger than your Java program, right? So if your Java program was, this is the answer for 1, this is the answer for 2, this is the answer for 3, well, you can't go on forever because one thing is your Java program is finite, right? So your input's going to be bigger, right? Right, so you have to make sure that your Java program handles all these really big inputs, right? And that's the core of computer science in some ways, right? How big can your Java program be? It could be a trillion lines long, but it has to be finite. And then what does it have to do? It has to work for every input, right? In particular, it has to work for inputs that are bigger than your Java program, right? Does that kind of make sense as a philosophy here? Right? All right. Right. So what we're going to do is we're going to take this statement and turn it into a game. All right? A game between the prover and the adversary. And the prover will have a strategy to win the game if the statement's true. And this adversary will have a strategy to win the game if the statement's false, right? Now, why are we doing this? Well, my story is that you guys have been playing games since you were little, and you have good intuition about games, right? Go home and ask a 2-year-old the game if you come up with an integer and I come up with a big integer. Will they understand it? Maybe not a 2-year-old, but a 7-year-old would, right? All right, so what's the game? Oh, we have a third player, and this third player won't come into effect until later in the slides, right? But the oracle, she assures you of things, right? And I've just added these slides. Before we didn't talk about the oracle until the end, and now I'm bringing her in earlier so that you understand the oracle from the beginning. All right. So the oracle, right? Who's the oracle? It's a burning bush, top of the mountain. You all know about oracles, right? She's helpful, right? So she's assuring you that for all boys they love, right? Right? Now, what are you going to do with this? If you had such an oracle, what would you do with her? How would you use her? What do you give her?
Information.
What?
Information.
Yeah, which? What? She's saying all boys love. You give her a boy, right? This oracle is great. You can give her any boy. And what will she do? No, she'll tell you that your boy loves. right? If it's your great oracle, you can bring her anything. And she will assure you that that thing loves, right? Right? Anybody, right? So we're going to hear anybody because usually it's the prover, but anybody can give her a favorite boy and she will assure that that boy loves. All right? All right, so there's a lot happening here. There's a difference between a local variable that's looping on a loop versus a variable that has sort of a constant, a real value, right? So for all b, that little b is looping over all boys, right? And now we want to give b a specific value. So let's call that specific value b sub for all. Why? It's a specific value that came out of the for all b, right? Everybody see that? So I can give her any object whatsoever. I'm going to give her a boy whose name is b sub for all, and she's going to assure me that he loves. Right? Does that make sense? And I'm going to put 4 of these little things up here, and I want you to memorize them all. All right? And what's this one? This one's saying assuring. If she's assuring you that for all b is true, who comes up with the b? Anybody, right? The prover could come up with the b, the adversary could come up with the b, and she will assure. Right? Everybody got that? Yeah? All right, because we're going to do more of them. We got 4 of them here. All right. Here's this proof by example, right? What about Bob? Oh, yeah, Bob's a lover, right? Okay, now let's switch over to something else. Now she's assuring you that there exists a B, right? You know, sometimes they put the little exists on top for those people who haven't learned them yet, but they're not going to stay there for the whole course, right? Okay, she's saying that there exists a boy that loves, right? Now you climb up the mountain. She's assuring you that there exists a boy that loves. What are you going to say to her? Come on, guys. Who? Right? Give me the boy in question, right? If I know, in fact, actually, let's go back to where these oracles come. Remember, I brought the oracle all the way forward into the and or stuff, right? It's the oracle is assuring us of the things that were our axioms are the things that we proved already, right? Versus what are we proving, right? If we proved already that there exists the boy, or it's our axiom, then we can say in our next line of the proof, we can say, okay, who is the boy? Let's give him a name. Tell me who he is. And let's give him the name. Here's a concrete boy whose name is B sub exists. Right? And she'll give you this boy right there. She gives the oracle gives you the exist. And she assures you that he loves. Right? And now, what's the difference between those two? We're very different.
That she brings you the boy as opposed to you bringing something.
Yeah, it all comes down to who gets to choose the object, right? If it's true for all boys, your adversary could come up with the object, right? If she's just saying that there exists one, it might be unique. And so she gets to come up with the object, right? You see, the game is proving these different things. Right? Yeah.
It's almost like you're having to bring up the case of where it exists.
Right. 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 If I say You know, you're at a party and I say you're always mean, then you get to say, no, what about yesterday? Was I mean then? Right? But if I say there was a time you were mean, right? Then what are you going to say? Oh yeah, when? Right? That's what you'd say at a party, right? It's really not rocket science. It's what we do. Right? She says, Bob, yeah, Bob's the lover. But the key here is here, look at, this is yellow, right? Versus this is red, right? Now, on the test, you're going to have to be doing these things. And I don't expect you to come up with colors. So in this one, you would say, the adversary says, what about Bob? And then the oracle says, yes, he's a lover, right? Or you could do oracle semicolon says, right? A semicolon, right? We're having a conversation here, right? People good? And people often say to me, how do we write this up? Well, just do what I did on the slides. Yeah, but in the slides you did bubbles. And that's partly why I started giving all the site examples, right? If you weren't here already, my plan is to post last year's test, right? You already have the previous year's test, right? But later today, I'll post last year's test, and then you can see how we do it, right? All right. Oh yeah, we did it already. All right. So now she's assuring you of this, and I put the brackets in, but they're normally not there. And what you do is you read it from left to right. All right? It's a game. People are going to provide these objects in the order from left to right. And if you think it doesn't matter, the order, who goes first matters, right? If he comes up with the integer first, I'm going to win, right? So going first matters, right? All right, so she's assuring you that something is true for all x. So she says, okay, give me an arbitrary, that's what we would say in 1019 in a math paper, we would say, let x be an arbitrary object, right? Where did it come from? It's arbitrary. But where did it come from? Oh, my adversary game. Why do we make it an adversary? Because this is an adversarial game, right? Let x be arbitrary is not let x be random, right? A random x is different than an adversarial x, right? So anybody can give her the x, and given the x, she then comes up with the y, right? Does that make sense? Right? So you first say, adversary gives me an x, and then she has to come up with a y. And what's the advantage of the order is that when she's coming up with a y, she already knows the x, right? And she can make it bigger, right? Are we running out of time? How are we doing?
Yeah.
2 minutes, excellent. Right? Everybody get this game? Now, we've only put in half of it here. Let's go over to the other side. Now, before we were saying we had a line which we knew was true, so the oracle was assuring it for us. Now we're trying to prove something, and the game just flips, right? I'm a prover. I need to play this game, right? To prove it. If I want to prove it, all I have to do is act like I'm an oracle, right? I'm assuring you it's true. If I play the role as an oracle, then that proves it's true, right? All right, so we just switch it, right? All right, so now if I want to prove for all B, then I say, let B be arbitrary. Let B be provided by my adversary, right? And if I want to prove that there exists a B, then I get to construct the B, right? Everybody see that? Everybody got the game? And then we're going to go over to this slide, more complicated. How do I prove this statement? I read it left to right. Give me an arbitrary X, right? Right, the adversary gives me an arbitrary X. I don't know what it is. I need to prove that there exists a Y. How do I do it? I make it one bigger, right? All right, so if you're in 1019, let me know if this is what, did you prove this in 1019? More or less, did you say, let X be an arbitrary integer? Let Y be one bigger, right? Note, this is true. Hence, that completes the proof, right? Have you seen these before? Is this a game? Right? Where did this X come from? He's bad, right? He's the worst case X. How do we know it's true? Because the worst case one was given to us by our adversary. And then I construct one. How do I construct one? It's a function, right? My at Y depends on your X. And then we prove it. All right, I think we're out of time. Everybody have a glorious Monday, Tuesday.
Professor, I have a question.
Do that too.